The scrape already works. You ran it by hand, it pulled the pages, the data looked right, and you moved on. The hard part was never that first run. It is running the thing again tomorrow and every day for a year, with nobody watching and knowing the moment it quietly stops. That layer, what decides when your scraper runs and what happens when it fails, is scheduling. It is the difference between fresh data and a table that went stale 3 weeks ago while you assumed it was fine. I run production scrapers for a living, so I have lived on every rung of this ladder, from a single cron line on one box to a full orchestrator running dozens of jobs. I have been paged at 3 in the morning because a schedule did something dumb, so I have opinions about when each tool earns its place. Today I want to walk the three real options, Cron, Airflow, and Dagster, what each is for, and how to choose without overbuilding. What scheduling actually has to do. Scheduling sounds like one job, run this at 6 in the morning, but the real work hides underneath. A scheduler has to remember whether the last run finished, it has to retry a failed step without redoing the ones that worked. It has to keep two runs from colliding when one runs long. It has to tell you when something broke, and, harder, when something returned nothing. Cron does the first sentence, everything after it is why the other tools exist. Cron is the scheduler that already lives on every Unix box you own. You give it a line, a time, and a command, and it runs that command on that schedule forever. No service, no database, no dependencies to keep alive. For a single scrape that pulls one source once a day into one table, Cron is not the lazy choice, it is the correct one. The best infrastructure for a simple task is the least infrastructure that does it, where Cron quietly fails you. The trouble with Cron is everything it does not do. It has no memory, so a failed run just vanishes and the next starts fresh as if nothing happened. It has no retries of its own, so a single network blip can lose you a whole day. It will start a new run while the last is still going, and now two copies fight over the same table. And its output goes nowhere you will look, so a broken job shows up days later as stale data, not an alert. Make Cron last a little longer. If you only have a job or two, you do not have to abandon Cron, you just shore it up. Wrap the command in a script that takes a lock so runs cannot overlap and exits loudly when it fails. Send the output to a real log file instead of the void. Add a heartbeat, a service you ping only when the job finishes cleanly, so a run that never happens sets off the alarm by its silence. That missing run is the scariest failure of all. The moment you outgrow Cron, here is the signal that you have outgrown it. You have steps that depend on each other, fetch then parse then load, and you want to retry just the one that broke. You need to reprocess last month because you fixed the parser. You are running more than a couple of jobs and cannot keep straight what runs when. Or a second person joined and needs to see what is happening without reading your cron tab. When any of those is true, it is time to climb a rung. What a DAG is. The tools above cron are built around an idea called a DAG, a directed acyclic graph. That sounds academic, but it just means a set of steps with an order, where each step points to the ones that must finish first. Fetch runs before parse, parse before store. Once your scheduler understands that shape, it can run steps in order, run independent ones in parallel, retry a single failed step, and skip the ones that already succeeded. That is the whole reason DAGs exist. Airflow, the workhorse. Airflow is the tool most teams reach for first, and for good reason. You write your DAG in Python, Airflow schedules it, and it gives you a UI where every run is a row of green and red boxes you can read at a glance. Each task carries its own retries and delays. When something fails, you click in, read the log, and rerun just that piece. Almost every database, API, and cloud service already has a ready-made connector. Backfills are where Airflow shines. The thing Airflow does far better than a pile of cron jobs is the backfill. It treats every run as owning a slice of time. This run owns Tuesday's data, that one owns Wednesday's. So when you fix a parser and need to rebuild the last 30 days, you tell Airflow to run that range, and it reprocesses each day in order. That only works if your steps are idempotent, but when they are, repairing history becomes one command instead of a manual chore. What Airflow costs you? None of that is free. Airflow is a real system you have to run, a scheduler, a metadata database holding all that run history, workers to execute the tasks, and a web server for the UI. That is several moving parts to install, secure, upgrade, and babysit, and everyone can break at 3 in the morning too. Standing all of that up to run one daily scrape is like buying a forklift to carry your groceries. Dagster and Prefect, the newer model. Dagster and Prefect came later and looked at the same problem from a different angle. Instead of thinking only about tasks that run, Dagster thinks about the data assets those tasks produce, the actual table or dataset you care about. You declare the asset and the code that builds it, and it knows what the asset depends on and how fresh it is. That fits scraping because you do not care that a task ran, you care whether your product's dataset is current and correct. It also leans on typing, so a run that returns the wrong shape gets caught instead of silently writing garbage. Prefect takes a lighter path, wrapping your Python functions as flows with little ceremony, both aiming at nicer local development and clearer visibility. Put retries in the scheduler, not just the code. Wherever you land, push retries up into the scheduler, not just the scrape. Yes, your fetch function can have its own backoff for a single flaky request, and it should. But the scheduler retrying a whole failed task with a growing delay between attempts is what saves a run when a site has a bad 5 minutes. Cron cannot do this at all. Airflow, Dagster, and Prefect all give you retries and delays as a setting on the task, so only a truly stuck job reaches you. Idempotencies is what makes scheduling safe. None of the retry and backfill machinery is safe unless your jobs are idempotent, meaning running the same job twice does no harm. If a rerun doubles your rows or corrupts a partial write, then every retry is a gamble and every backfill is a risk. So key your records on a stable ID and write with an upsert that overwrites cleanly instead of appending. Get this right once, and the scheduler can retry, reprocess, and recover from a crash freely because a repeated run always lands in the same place. The failure nobody catches, the silent empty run. The worst failure in scheduled scraping is not the crash, it is the run that succeeds and returns nothing. The site changed a selector or served an empty page, and your job finishes green with 0 rows, and Cron, even a naive Airflow setup, calls that a success. So build the check yourself. At the end of the run, count what you collected and compare it to normal. If you usually pull thousands of records and today you got 12, fail the run on purpose and raise the alarm. A green check mark on an empty table is the most expensive lie in this business. Alert on the shape of a real problem. Tune your alerts to real breakage, not noise. A few failed pages out of 100,000 is background static and should wake nobody. What should wake you is a whole run failing, the success rate falling off a cliff, 0 rows where you expected thousands, or, sneakiest of all, a run that never started. That last one needs a heartbeat, a ping whose absence tells you the scheduler itself is down. An alert that fires on every hiccup gets muted within a week, and a muted alert is no alert. Do not overbuild before you need to fee. The mistake I see most is not too little tooling, it is reaching for too much. Someone reads about Airflow and Dagster and stands up a whole orchestrator, database and workers and all, to run one scrape a single cron line handled fine. Now they maintain a distributed system for a job that never needed one. The right move is almost always the smallest tool that covers what you have today. Climb the ladder when the pain is real, not before. Choose by scale and team size. So here's how I actually decide. 1 or 2 scrapes, running solo, no complex dependencies. I use cron with a lock and a heartbeat and I am done. A handful of pipelines with real steps and backfills, or a small team that needs to see run history. I reach for Airflow because it is proven and everyone can learn it. A data-heavy setup where freshness, lineage, and typed outputs matter more than raw scheduling. I lean toward Dagster or Prefect when the work is irregular and Pythonic. The tool follows the need, never the reverse. The honest limits, let me be straight about what scheduling does and does not do. Running your scraper reliably on time makes your data fresh and your failures visible. It does not change what you are allowed to collect. Public data still, a robots file still respected, a Gentoo pay still held, and an official AP or bulk feed still preferred when the site offers one. A scheduler decides when your scraper runs and how it recovers, nothing more. It does not make a scrape welcome where it is not. I run all 3 of these in production right now, Cron for the small stuff, and a real orchestrator for the pipelines that feed everything else, so this is the ladder I actually climb, not theory. If you want the full versions, the written guides with working Airflow and Dagster setups, the idempotency patterns, and the checks that catch an empty run, plus the picks I actually use, they are all at dataresearchtools.com. Reliability is the unglamorous half of scraping that nobody films, and it decides whether your data is still flowing a year from now. So, to recap, Cron is right for one simple job, so use it and shore it up with a lock, a log, and a heartbeat. Move up when you have dependencies, backfills, more than a couple of jobs, or a second person watching. Airflow is the proven workhorse for scheduled DAGs and backfills. Dagster and Prefect give you typed assets and better visibility, and whichever you pick, put retries in the scheduler, make every job idempotent, and alert on the empty run, not just the crash. Do not build the cathedral until you truly need it. Subscribe for a new scraping infrastructure breakdown, and I'll see you in the next one.